Okay, well, welcome everyone to the Stream Macroinvertebrate workshop, the afternoon breakout session of our MiCorps conference here. My name's Paul Steen. I work with the Huron River Watershed Council. I'm the Stream Program Manager of this part of MiCorps, the Stream part. With me is Tamara Lipsey, who works with Eagle and does more field work than anyone would ever want to do on macroinvertebrates. So this one above everything is affected by our change to virtual, because what we had planned for you was some presentations, but most of the time was supposed to be spent kind of working together in teams, identifying macroinvertebrates together. The idea was that we were going to collectively share our knowledge and all improve on our identification skills. So obviously we lost that part of it. Let me just proceed forward so you can see the new ideas here. So this is what we're going to do in this workshop now. I'm going to start off with showing everyone a look at the new data entry system for the MiCorps database. Now this won't apply to everyone. It will specifically apply to people who are running these programs and need to enter the macroinvertebrate data, but it's been hotly anticipated item for those people. Because the functionality has been down for a while now, and people want to get their data up so they can share it with Eagle and other groups. So I'm going to show you how to do that. Then we are going, Tamara is going to take over, and we're going to do a presentation that will be applicable for everybody, which is identifying macroinvertebrates. Lots of pictures, both good for both beginners and for advanced folk, because we have some family level identification in here too. So hopefully everyone can still learn from that. It's probably more suited for beginners, but Tamara will make sure that she gives tips for advanced people too. Then when we're done with that, we'll go back to me, and I have a presentation on some of my initial experiences using this water quality rating that we do, what the data means, what it doesn't mean, and hopefully that can generate some conversation. So that's kind of the plan for this afternoon. Now I'm going to get out of this. I'm going to show you this thing in just a second, but I'm going to get out of my PowerPoint because I'm going to go online. All right, to our website. Tamara, do you see that all right? Website up. Okay, so I am at thank you. I am at the MiCorps website. Joe mentioned that this is getting an overhaul. That's something we're actively working on. But in kind of preparation for that, we are first overhauling the whole data exchange functionality with the intention of just migrating that over to the new site. So we're improving how things work with in here, basically. So what I want to do is walk you through that, how that all is going to work. But to start, I was just going to highlight a new thing for all of you to be able to use. So if you're in here and you go down the stream documents, we now have, scroll down, and nicely labeled here, new. Okay, so new, Macroinvertebrates of Michigan. This is hot off the presses as of yesterday. I would consider this a near final draft. I haven't given Tamara proper time to to edit it. So near final draft, but I wanted to share it with you today. If there's an update change, I'll just re-upload the new file. And this is thanks to my colleague Kate here at the HRWC office. So what we have is just some really nice black and white pictures of the macroinvertebrates at that level that we're asking you to identify things to. So it's just a one-pager. It's front and back. The idea is that you print it double-sided and you can laminate it, and then you can let your folks use it out in the field or for ID days or what have you. So it's a really nice resource that it's updated from the one we had before, which was 2006 era. So we got this nice new graphics, high resolution, everything, really good looking document. So that is there for all of you to use. Okay, so now for those who are actively holding data, you've been waiting a year or more to get this data into the system. This is what you do. I'm just going to walk you through the steps. I suggest that you just kind of listen and follow along, and then attempt it yourself later after you see all the procedures. And this is being recorded, so you can also go back after this is recorded and watch it and pause and start and pause and start as you need to, so that you can make sure that you understand everything. So first step, many of you will have old stream database logins. None of that is going to be working anymore. Everyone has to create a new account. And the way you can do that is you go to Streams and you go down here, Login, Register. Okay, so let's do that. And it will bring up this dialog box. We're not going to use this one. This is one of my accounts, but I'm going to create a new account. So don't have an account, register here. And I'm just going to do a dummy account for our time here. MiCorps conference, random password. Hopefully that works. Yep. I'll just put it under myself and my home address. So if you skip any of these things, of course, it's going to tell you to go back and fix it. The email has to be unique, all right? So you'll create one account, and it will, with your work email or whatever email you want to use. I made up a dummy email. Okay, phone number is also a unique number. You can't have multiple things under the same phone number. That's hopefully unique. Okay. MSU programs, which MiCorps is now under, require demographic information. So, but you can give as little or as much as you want here. Right, okay, so I think I got all the requirements there. And then you're choosing your program. So this is the same steps you follow if you're a lake user or a stream user. And you can see if you're doing both, if you do lakes and streams, you can pick that. I'm just going to pick streams for now. So I am a stream user. And let me remember, I have to get this MiCorps conference to log back in. All right, submit. Okay, I missed something here. What did I forget? Oh, okay. Okay, so that is properly, I am properly registered, and now I need to log in. MiCorps conference, my password, submit. All right. And this is what it looks like when you first have a login and you're registered. What we decided to do was give everyone the ability to create like a hierarchy within your data. So we're gonna, at the top level, to help you organize everything, is an organization. So when you first get in here and you don't see anything else filled out, that means you need an organization. So, you would type in whatever your actual organization is. Huron River Watershed Council for me, but I'm gonna just I've created all kinds of organizations already. Test organization 99. This is not, it's kind of almost an artifact in the system. It's not an organization that you're gonna have to put an address under and a phone number and contact information. It's more like as a bucket to organize your monitoring sites. So I'm going to create this organization. Okay, so that exists now. I can say view my organizations. So I am in test organization 99. And if you say, I'll go back a second. If you say view, it gives you a bunch of options here. Here I am, here's my email. The way we've set this up is that you can invite people to join your organization. And that's because you, as a stream program manager, may have people under you, volunteers or other staff, who also are going to want to be in this organization with each other. That way you can ask people to enter data for you, for example. So like you'll all be combined in this organization. So if you want to do that, you can go down here with this blue thing, invite volunteer to this organization by email. So you can do that. That person will get an email and nudged to create their own account, and then they will be brought in as an assisting volunteer into your organization. Then they will be able to enter data for you.
Hey, Paul, if you want to show that off, you could go ahead and test it, and I could and show that end of it.
Yeah, let's do that. Oh, so I should say Dylan Hoffner is here. Dylan built all this. This is from scratch, right? This isn't like a canned program, so we're grateful that he did this. Dylan, you've probably been invited a bunch of times already. What email should I use?
You could just use my hofnerd at msu.edu.
Hofnerd at msu.edu. Did I get it right, or did I have too many F's?
That is correct.
Okay. All right, so let me stop sharing and I'll go to Dylan and he can share his screen.
Okay. Alrighty, so you will receive an email just like this asking you to join the organization. And all you have to do is click this link. Well, first off, you got to make sure you're logged into the right account. Or if you do not have an account or you're not logged in, that's okay. But I was logged into the wrong account. So I'm going to make sure I am logged out. And I'm going to go back to that email. And I'm going to go ahead and click that link. So what that'll do, that'll send me into the login screen because I am not logged in. And let's see. Okay, so now I'm logged in. So now I can go back and click that link. And it does a lot of back-end stuff. And we can see that I have now successfully joined that organization. So now I could click in to view it, and I could see Paul right there. And we could even see my invitation information right there. And I will let Paul take it back over.
Yeah, so that's all working well. It's a good way to get people to do your work for you, right? That's what we're trying to do here. Get the volunteers to I have to figure out how to share my screen again. Do your data entry for you, because all of us have a lot of data entry here. All right, just give me a second. I'm trying to find the right window to share my screen. Oh, there it is. Okay. All right, so we're back. I can click to go back to my organization. I will. Yeah, so look at this. Now Dylan's in my organization. If for any reason you needed to disband it, that will not delete your data that you will eventually enter in. It's just deleting that overall kind of umbrella or organizing of how all this works. So we're going to go back to the dashboard. Okay, so you set things up. Now it's time to actually enter your data in. Add streams to your account. So we're going to start here. Got a little bit of code error in the top there, Dylan. This is still, I would say this is functional, but we're still running into little bugs. This is like right off, like just finished type of thing. So you have to bear with us a little bit. And then, so find your stream. If you have already been monitoring and you already, in the old days, have been entering data, these streams already exist. They'll exist by field ID, and you can look for them. For example, I know that all of my data has the prefix HRWC on it. So I can type HRWC. Now I see all my sites that already exist in the database. So I'll come back. I'll show you how to make your own new sites. But for now, this one already exists, so I'm going to pick it. You can also just look at the entire list of sites. A little bit harder to find things in there. It's easier, of course, to type in and start doing it that way. I want to enroll it into my test organization 99. I'm going to add this stream. Success. Okay. We're just going to go back to my organization so you can see what this looks like. Okay, so now if you go into your organization, you will see I have this stream site has been added. And let's say you have some data you want to enter. That's kind of where we are in the next step here. Oh, and so I should just mention, if you are sampling 60 sites and you add them all to your account here, they will all be listed. And then you just have a quick hit of view if you want to see what's going on there. So here we are. This is the site I want to enter data for. And we, thanks to Dylan, we have our new 2 data sheets. The MDE order level is the basic MiCorps identification under the new system that we just recently started. The family level is that more advanced functionality. And then if you're still entering data through the older methods, like you have like Heather mentioned in her presentation, like she still has some people who are using the older method. You can still do that. It says archived methods now. All right, so let's say we're going to enter data for this site. Go here, and it's all the stuff. This is the first side of your data sheet. Just quick fill this in here so you can get a sense. And then we have on the front side of your data sheet, all the habitats are present or absent. I think if you leave it blank, I think it just goes to absence. We'll just fill it all in here. Collection finish time. Paul, ID confidence. Highly confident that I got it all right. Okay, so we're entering that. Oops, I skipped something. No site condition issues. We'll save that. Okay, so that was the front side of the piece of paper. Now, this is where you enter abundance in for the different things you found. All the way down. If you do the family level ID, of course, it's going to list all like 200 possible rows here. I don't think I'll show you that. Just know that it exists and it works. Okay, we're going to save information. All right, so now There we go. And you can come back and rewatch this stuff. So,
Hey, Paul.
Yeah, any questions or?
I just thought I would add that, like Dylan said earlier this morning, like this is to be a really great time since we are still like working on things, that if you are like, man, I wish when I press view data, it would show me this. Or I wish when I downloaded an Excel file, I could see this. I think it's just a good idea, a good time to email Paul, and he'll have a little folder in his email account to put ideas, because that's what Dylan's asking of us is ideas. And we might not think of everything because, well, I haven't entered data at all. So just I thought I'd put that out there as an idea.
Yeah, absolutely. Like we're in progress now. I mean, we're working on this every day. So now is the best time rather than try to shoehorn an idea in later, right? Getting it now while we're in progress is the way to go. Okay. All right, so I think that's it for me for now. I'm going to come back and talk more later. And I'm going to pass it over to Tamara. Though she told me I'm allowed to butt in during her presentation. So I'll let you go, Tamara. You're muted.
The presentation might look familiar to some of you because we did use it when we did our stream training virtually in 2021. So it is that presentation with some additions added. Paul, are you going to need 20 minutes at the end? Is that what you said?
Yeah.
Okay.
Yeah, when's it supposed to be done?
Well, I thought if I wrapped up at 2:15, that would give you like 25 minutes.
That's great. If you can do it in that length of time.
Okay, we'll see. But I'll try to move along. But this might help. I wanted, before I got started, actually, just everybody to turn on your cameras. And then I'm going to just ask you to turn them off based on your experience identifying macroinvertebrates. So I'm going to bring up my presentation while you're all putting your cameras on. Which screen do you see, Paul?
I don't think I see it yet.
Because I haven't shared the screen yet. I only just turned it on. Hold on. Where is I didn't practice this earlier.
That's okay. I have 3 monitors, so it's like it gets really confusing when I start
sharing. There's the share screen right in the middle of the booth. All right, so I want you guys to be able to see this screen. Okay, and now I'm going to turn on the presentation.
Yep, I see it. Well, I see your blue screen, your background. Yep.
All right, good. Okay, so I want everybody to turn off your screen if you are a newbie, like you're just learning macroinvertebrates and this is really all new to you. Just want to get an idea of how many beginners we have. So I have a few, but a lot of you feel a little more confident than that. That's great. Okay, how many of you think I can get to order really easily, but anything lower than that, I have trouble with?
Wait, do you want us to turn our cameras off or to keep them on?
To turn them off if you think you really got orders and you can do families and you can do everything else too. But if you only can go to order, turn off your camera. It's just the people without their videos on, I know. So that's a good portion of us. So there's not that many who go down to family level. So how many of the people who are left can do any family? So leave your video on if you can do any family, not just the MiCorps families, but any family. Okay, so there's not too many experts. And then leave your camera on if you can do genus species, and I would turn off my camera.
Yeah, me too. Depends on what family it is. Yeah.
We got a couple who can do genus species, maybe. All right. So that just helps me. Sounds like we're all like, there's a lot of people who can go to order, not as many who can go to family. It just helps me with what detail I'm going to go into. But it didn't seem like there are too many beginners. So I won't go over this slide too much just to save time, but there is an animal classification for all animals, including humans. And that is why we ask you to do these funny things like identify things to an order in a family. It's just part of the animal classification system. And that's how scientists can talk about things with each other. So here is some general diagrams. On the left, we have a stonefly, and on the right, we have a caddisfly or a trichoptera. When I'm pointing out features, I'm going to talk about the head usually, and this is the head right here of the trichop. Then I'll talk about the thorax, which is the middle part of the macroinvertebrate. The thorax here is these three, or actually, nope, these three, the top three. And then I'll talk about the abdomen, which is everything else. And down here, it's all of this part. And then I'll also be talking about prolegs, maybe that come off, or anal prolegs. It's just a fancy way of saying things that come out their butt. So we might talk about some of those things too. So the pictures, most of them or many of them in this presentation came from this website that I found that was great when I found it a couple of years ago because I hadn't seen it yet. It's called Macroinvertebrates.org. It's from the Carnegie Museum of Natural History. And it has all these great pictures. You can zoom into body parts from different angles. It was developed for Eastern North America. So there are some differences with what we find in Michigan, but overall, it's a super great resource. And on that website is a key that you can go through. There are lots of keys out there to help narrow your macroinvertebrates down, but this is the one from that website. And the goal for today is primarily to go over the required MiCorps group identifications, but because there are many of you who are learning families, I want to get some of the details too, and to answer questions. So I'm going to stop after every order or so and see if you have any questions specific to that order. Like, I can't ever find this, and see if Paul and I can answer that question quickly. If it's something more detailed, we'll get back with you. Okay, so this is the same taxa list that's found on the order level data sheets, and order level is kind of in quotes because not all the taxa are at the order level. With the new macroinvertebrate metrics, there are some at the family level. However, there's also a true family level data sheet available, which if you were willing or could find an expert to help your group out, the family level data sheet will lead to a more defined, accurate overall score. The taxa are listed from most sensitive to least sensitive. And when I go through my presentation, I'm not going to go from top to bottom because it makes more sense to talk about orders together. But I'll try to keep it very clear with you. We're going to start with the Megaloptera, which there's two families we ask you to go to. We ask you to go to Corydalis and Cyalids. So here's a drawing of both of those families. Each of the organisms that I go over, I'll always have the phylum and class and the order at the top here. And then I'll go to families down below. The first family is the Corydalis. They are the sensitive one. They're a very sensitive species. So, I mean, family. So we'll find them in very clear, clean streams. They have 6 legs because in most of the macroinvertebrates we have UID have 6 legs, except for a few because they are insects. They have these projections that come off of their body. And for their tail, they don't really have a distinct single tail. They have what's called these prolegs instead. And they're generally pretty big. I mean, obviously they start small. So when you find a small one, it's kind of fun actually, because usually when you see them, they're usually 2 to 3 inches. They're often, I usually find them on pieces of wood that I pick up and scrape off, or they are found on big pieces of cobble in riffles. The other family is the Cyalid family, and they are less sensitive to pollution. So they have a pollution sensitivity number that's a little higher. They're found in silt rather than cobble and gravel. And they're generally quite a bit smaller. I have this here to make, if you printed this out, the presentation, that's more realistic for their size or smaller. And they also have these lateral projections, but they also have a single tail at the end versus these multiple prolegs at the end. And for each organism, I have a real life picture. So here is that Corydalis. They're also called Pilgramites or Dobson flies and fish flies. And then here's an alder fly, and you can see its single tail. And its filaments are also a lot finer. The Corydalis has really thick projections, and they look a little scary, and they do bite. So make sure you have your volunteers use forceps if they see anything like this. And that's all I have for Megalopteras. Does anybody have any questions before I move on? Or do you want to add anything, Paul? I can't see the
Gotcha.
thing whatever you
people.
call it. Yeah, the people very well. So if you could keep track of that.
Okay. Yep. No questions, and I'm shaking my head. I don't have anything to add.
Okay.
Those are the easy ones right there, right?
Yep. Okay. Thanks a lot. All right. So we'll move on. So now I'm going to move on to stoneflies. Stoneflies are one of my favorites. They are pretty neat looking. My favorite is called a pteronarcid, which I think I might have a picture of later. Stoneflies in general are very sensitive. And so if I see stoneflies, that usually means I'm in a nice stream or river somewhere. My family is so well trained that now I can just send a picture of a pteronarcid and not have any text with it. And they will text back to me, "Mom's having a good day." So these are one of my favorites. So all stoneflies have 2 tails, 2 filaments that are coming off their ends. They are insects, so they have 3 pairs of legs. And they also have 2 tiny tarsal claws. When I say tarsal claws, it means at the end of each leg, there are these 2 little, they kind of look like this at the end of each leg. They have really long antennae. Sometimes they have gills on the undersides of them, but sometimes they don't. And they are often found in gravel or cobble or on cobble and wood. So here's some different families you'll run across of. Generally, the only ones that I feel super comfortable identifying out in the field to family are the pteronarcids, which is my favorite one there. And then purlids, because purlids have gills underneath their armpits, and they do these push-ups. They're awful kind of pretty. I call them pretty purlids. I also can identify nemurids for the most part out in the field because they have gills on their necks, but the rest of them, I bring them back. I even bring back quite a few of these purlotids because sometimes you can't see the gills real well out in the field. And then once they don't have gills, it gets a little fuzzier for me. They are all a little bit thinner and longer. I don't know if I've ever seen a Taniopterygid before.
Tamara, you have to come to our winter stonefly search because that's when January, when we go out and look, that's when we pull those
Love
in.
to do that. I've never done that. Biologists
Yeah.
talk about that, and I never have done that. Yeah, you'll have to send me the date for that.
Yeah, sure. And the January.
All right. And so that's all I have for this slide. Do you have anything else to add? Does anybody have any questions? Okay. This is just a better view of their gills. I have a little video of push-ups, but I don't think I'll do that today. They just do push-ups to move water past their gills if they're in still water. But not all of them have gills. Okay, so now we're going to move on to caddisflies or Trichoptera. Their pollution sensitivity is an average of 3.2. They also have 3 pairs of legs, but other than their legs, they're kind of worm-like. They have kind of hard plates on their head right here, and then on their thorax, but not always. Sometimes these are not as they're hard. They might be soft as well, but the head is always hard. They have these prolegs at the end of their bodies. They often have cases made of sand, leaves, and twigs. If you Google on YouTube, think caddisfly glue, there's a pretty cool 4-minute video that I use for kids and adults to show them making their cases. But there's many types that are free living. So they're found in a lot of different types of habitats. Here's some examples of caddisfly cases. This is a Hydrocycode, looks like a little snail shell. This is a Brachiocenterid. It has like log cabin-like 4-sided cases. But there's all kinds of cases that are out there. When you're going to family, I usually try to bring at least one back of every kind, except for these ones that I just pointed out to you. Because there are several different families that have these kind of cornucopia shaped ones that then later might turn into a different kind of case, but when they're young, they start with stones. So in general, I often will bring one back. Now you guys bring everything back, so that's easy for you. But I guess my point being is that they are a little more difficult to identify without a microscope. Here's some real life pictures. There's a Hydrocycode in real life. Limnophilids, there's lots of different genuses of limnophilids, so there's lots of different kinds. Here's a Brachiocenterid. Oh, go ahead.
Yeah, so Helicocycode is really interesting because that's the one that looks like a snail shell, right? But
right.
When you get it under a scope, you see all the individual grains of sand. So that one's, all you have to do is learn the name basically, and you have that one. That one's really easy to identify. Now the Odontoceridae is really interesting. That's a rare one, super clean water required. And we have a few of those in the upper part of the Huron River where it's like the best area, but nowhere downstream. So like I always associate that one with just like the best possible locations. It's called a strong case maker because unlike other caddis, you can squeeze that one in your hands and it will withstand the pressure of your fingers. It really has either through construction or the silk it uses or whatever. It's really, really strong. I mean, I think if you really wanted to break it, you could. But compared to the others, it's quite tough. Limnophilids have tremendous diversity of cases. They can be rock, stone, grass, leaf, anything. So limnophilids are actually probably the trickiest one to identify by cases. But brachiocentrids will almost always look like that with the log cabin case. There's a few of the tiniest brachiocentrids that use sand, but almost if you see one that looks like that, it's going to be a brachiocentrid. So cases are really, really useful for ID at the family level.
But when you guys put them in jars, so I do a lot of live ID for my job, everyone. But when you put them in alcohol, they often will crawl out of their cases. So I just think that's one thing. It might be helpful when you're separating. I don't know how you guys jar them up, but it might be helpful for you to jar tricops up into at least different what they look like from their cases before you take them back. Otherwise, you have a jar full of cases with organisms that have crawled out. Is that right?
Yeah, I mean, not every single one will crawl out, but I don't know, 25% of them will.
Yeah,
definitely. So it's not a bad idea, especially if this is all new to you and you're trying to learn things by cases.
yes.
That's a good idea.
So then there are the free living caddisflies that don't have cases, and these actually, I have learned to identify some of these based on their movements, but it has taken a really long time. And some of our newer biologists who are actually entomologists are like, you're crazy, Tamara. You cannot make sure you identify something by the way it moves. But I've been kind of doing a non-scientific survey, and I think I can. But anyways, there are a lot of free living caddisflies out there with no case. And again, you'll have to look at their mouthpieces. You'll have to look at how many, if they have hard sclerotalized, they call it, pieces on their thoracic, or if they're membranous still. There's things like that that you'll need a microscope for a lot of times. All right, anything else on caddisfly before I move on? I wanted to point out that in the new MET scoring system, that no matter if they have cases or if they do not have cases, they're all counted together as Trichoptera if you're using this higher level data sheet. I believe in the old system, the net spinning caddisflies were in a different sensitivity grouping, and for this they are all counted together and then multiplied by the 3.2, correct?
That's right. Hydrocycodes, which are the one on the right from the former slide, are super common and found everywhere, but the problem is that too many people are confusing the other two for hydrocycodes. So it was just too much of a source of error to ask people to distinguish between all of these. So it made the decision to just group them together. Hydrocycodes actually have if you were to do this by family breakdown, have a 4.0. So they're not too far off that average of 3.2. So I don't think we're losing too much in data accuracy to summarize them the way we are now. And the hope is that it makes life easier on your volunteers.
Okay, the next one is mayflies. Many people are familiar with these because they hatch in really large groups at certain times in the summer and can be found covering cars and buildings, and fishermen love these hatches because they tend to be good times to go fishing. They are also fairly sensitive, but some less so. They have 3 tails instead of 2 most of the time, not always. And most of the time they have long antenna. They also will have, some of them will have feathery plates on their abdomen, and that is gills. And they're found in many different types of habitat versus stoneflies, which are found mostly in high quality streams. There's always exceptions to those things. This is one type of mayfly called a Batiscid. I always get kind of excited to see them. I don't see them all the time, and so being the nerd that I am, I think they're cute. They remind me of turtles, so I call them Teenage Mutant Ninja Turtles. That's how I remember them. This is a baited. They have 2 tails versus the 3 tails, but they do have these long antennae. Here's some other families. Isonychias, they scoot around super fast and are generally larger than baitids. That's how I can tell them. They have, like, I don't know, a bigger, like almost helmet-like head too. Ephemerids are the burrowing, one of the types of burrowing mayflies. There, excuse me, there are more than one type here in Michigan. This one's a hexagenia. Heptageneids are pretty easy to identify. They're really flat and their eyes bug out on the side a lot more because they are so flat, and they're usually found on rocks. Baitids are really common, and they skirt around really fast as well, but their head and their body isn't, like isonychias are almost striped, where baitids are usually more plain. There are also a couple of families that have gills that are certain shapes. This is called a Scenid, and I remember those because their gills are kind of square shaped. There's and this is a podomantid. The gills are on the abdomen. That's what's most important with stoneflies. They're found more on the thorax. Any questions, comments on stoneflies? I mean, sorry, mayflies.
Nothing's popping up, but everyone can know that they can either ask out loud or type it in the chat.
All right, so we will move on. Those are more of what we call the EPT taxa, or the Ephemeroptera, Plecoptera, Trichoptera taxa, that are more sensitive, and the number of EPT taxa in itself is a good metric to look at to see what the water quality of a stream is like. So now we're going to move on to dragonflies and damselflies, which everybody loves. And I don't know, I feel like sometimes volunteers find out they're not as sensitive. They're a little disappointed because they're so beautiful as adults. So in the case of dragonflies and damselflies, they're both the order Odonata, but they have suborders. So dragonflies are in the suborder Anisoptera and Zygoptera. Here's an adult, and then here's the juvenile. For the dragonflies, they have a more stout body. They're not long and thin like the damselflies. They have a labium, which they can move out to catch prey. They have 2 pairs of wing pads, so one up here and then one down here. And they have large eyes. And then the end of their abdomen has 5 stiff points. Here's several photos. Here's one of one emerging. If you're going to go to family, you often have to look at their labium and look at the indentations on there. So there are a few families that you really have to look closely at these and to tell the difference. It's the libellulids and the credulidae, I think. Let me see if there's anything else. I look at their antenna, which we'll get to in a minute for one of the more sensitive dragonflies. So I look at their thickness. These are really thin. Those look a little bit thicker. I also look at how stout their body is and how long their legs are if you're going to family. Macroinvertebrate have really long legs and are really flat and have bigger bodies generally.
I always think those look like spiders to me, Tamara. It's like if you see a dragonfly that looks like a spider, but it has 6 legs instead of 8, it's probably a macromeid.
Right.
That one in the bottom center.
So there is one family called the Gompidae family that are much more sensitive than the others. So in the MiCorps scoring system, they are signaled out. They have a 4-segmented antenna, which is kind of hard to see, but the biggest thing is that they have really like chunky antenna. They're not thin and long. They're really more chunky and often will look like they have balls on the ends of their antenna. And then they also have a very flat labium versus some of the other ones I mentioned have more of a scoop look to them. And here is a live picture of one. So you can see they look like almost 2 little eyes sticking out, those little perfect circles. They're not always like that. This one is not as obvious, but that's the biggest feature for them. So you can have your volunteers separate ones that have really big antenna, and that might make your job easier later. All right, the damselflies, they have a slender body. They have 2 pairs of wing pads and 6 legs. They also have that labium that they reach out to capture things with. And they have 3 tails versus the 5 different appendages coming out. And their long thinness is really a good indicator for them. When you're going to family, I don't ever see Lestidaes, so I'm not sure why. I just have not ever seen them.
They're more, they're more lake-like. So okay. Wetland or lentic systems, lake systems, not so much rivers.
Okay, so probably a lot of you won't be finding these either. Usually it's just the families are pretty easy to go to with damselflies. They either have these really long straight antenna or they don't, and the antenna are harder to see. So if the antenna are harder to see, it's this one, Synagrionidae. Or if they have the long antenna, it's Caelopterigidae. I'm sorry if I'm mutilating the words too, Paul. I have a fish background, really. So there might be some 3-tail confusion between mayflies and damselflies. The biggest thing is these, they don't have gills along their abdomen. It's just the body, where mayflies will have different little flaps and things for their gills along their body. How am I doing so far? 2 o'clock. So next we're to beetles. It's quite a bit different than ones we've reviewed so far. They all have these hard bodies. They're generally oval shaped, and they have chewing mouth parts. They have well-developed eyes, and they're found in many different types of habitats, but they like slower flowing water and vegetation, so they can live without as much oxygen. Both the adults and larvae live in the water, but they look very different from each other. This is just a close-up of all their mouth parts. They crunch and chew, and it's really complex and interesting. Hard to tell the difference between the antenna and the mouth parts sometimes. Here's just some different kinds that you might find. Riffle beetles are also called elmids. There's different there's whirligig beetles, which you find on top of the water, swimming rapidly around. There's predaceous diving beetles and crawling water beetles as well.
One thing I'll point out, Tamara, whirligig beetles are easy to tell when you're out in the river, you know, but when you put them in alcohol, suddenly you lose that. Where'd you pull them from? But one thing about whirligig beetles is they actually have 4 eyes. They have eyes on the top and eyes on the bottom of their body. It's really weird, and nothing else is like that.
That's right. I forgot about that. Some of you might be in watersheds where there's an endangered type of crawling water beetle as a haliplid. It's called the Hungerford beetle. And that's more in northwestern part of Michigan. Here are the larvae, so you can see they look a lot different. Some of them are, I feel like, easy to identify in the field. This one reminds me of a porcupine, so I can always remember it's a haliplid if it's a porcupine looking one. Other ones, they all have these big mouth parts still, and they have lateral appendages a lot of times. So sometimes when you're trying to do down to family, it gets a little bit more difficult because of the similarities. Elmids are pretty easy to tell because they don't have those appendages coming off of each other. The eye spots are usually visible. Like I said, you can see the mouth parts. They have segmented legs with 4 to 5 segments each. And sometimes they have hooks at their endpoints, at their anuses. I'm just going to see what I have. There's a lot of larvae that look similar, and it's expected. The first 2 are beetle larvae. But then the third one is the alderfly, the cyalit that we went over early. And this is a teeny tiny choroidalid, which, like I said, you don't always see. And then we have a beetle again. So this presentation is recorded, so you can look at this later, but this is a coworker made for us to help simplify things. So I take this out in the field with me now. There's a single terminal appendage, it's probably a cyalit. If it's not, then you look at their claws. Is there 1 claw per leg? And if yes, it's a hydrophilidae. If no, you keep going. Are there 4 hooks on the last abdominal segment or the anus? No. If no, it's a diticid. And then if there are paired terminal appendages, and it's yes, it's a choroidalid. So this is just a cheat sheet that one of our biologists made for us. You could also confuse a caddisfly larva with a beetle larva. You need to use multiple clues, like does it have plates on its thorax? How many, does it have anal hooks? Caddisfly will have 2 hooks, where coleopterans will have 4 hooks. So there could be some confusion to get started with these as well. There's one beetle that's really unique. We don't find the adults in the water. They're water pennies. They're found attached to rocks. But I wanted to point out again that in the new scoring system, water pennies are not separated out from the other beetles. They're all counted in the same order and multiplied by the sensitivity rating of 5.1. Okay, so now we're moving on to flies. There's so many kinds, and they're very small. They all look soft-bodied and worm-like. They don't have legs. They don't have wing pads. And many of them, you can't even see their head very well. Sometimes they have things sticking out their butt that look like a tail, but many times they don't. So with the MiCorps scoring system, we have 3 places where a dipteran might be placed. We have our sensitive ones, our somewhat sensitive ones, and then our tolerant ones. We're going to start with the sensitive ones. There's 3 types in this most sensitive one. And then remember, there's 3 types in the least sensitive, and then everything else goes in the middle one. That's a like just offhand way to remember it. So in the most sensitive, we have Aetheridae, Blepharidae, and Dixidae. The Aetheridae, they're almost always found in swift water, I find. And they burrow down into the gravel. So when you do gravel kicks, that's when you're going to find them. A lot of times they turn this green color. I'm assuming it's because they're eating algae, and that's how they turn this color. They have a pair of long tubercles fringed with hair. They often have these little tiny prolegs. They're not true legs, but they're little suction cups. And although they are often green, not always. The Blepharidae are pretty unique looking. There's nothing really else that looks like this, I don't believe, and I don't find it very often. I think they are found in really awesome waters as well, which I do sample some awesome waters, but I don't find them very often, if at all. I don't know if I've ever seen one. And then Dixids could be confused with a mosquito larva. I'll go over that in a minute. They have flat terminal lobes with hairs on them. They also have prolegs that have little hooks on them. You can see the head. That's one thing that's noticeable about them. And they are found in shallow or slow water with plants. And go ahead.
Oh, my thing for this one, because for me they look so much like midges, but they're almost like normal midges. But it's like a midge with a broken neck, because their head is almost always on this weird angle compared to a midge, which maybe would look more of like a straight on head. This one always seems to have its head up tilted in a weird way. So that's when I see something, usually with just my eyes, that looks like it has a broken neck. I'll look at it more carefully under a microscope.
Okay, anything about these 3 that people have questions about? Okay, so now we're going to go to the 3 that are considered tolerant. Those are mosquitoes, rat-tailed maggots, and soldier flies. Mosquitoes, their head capsule is also visible. That's one way to tell them. And they usually have, they do have fused thoracic segments. So it's kind of like a ball. Their thoracic area is just wider than the rest of their abdomen. They're often found, or they're almost always found in slow water because they can breathe with these little tubes that go to the surface. And like I said, they might be confused with a mosquito. I think the biggest thing for me is finding this big inflated thoracic area. When they're alive, dixids float at the top, and so do mosquitoes, but this little black head is more visible to me. I don't know, Paul, if under a microscope, if the black head is still visible.
For the dixids? Not always. Like the one on the top there, for example.
It's not very dark.
Yeah, it loses some of its color.
So go with the broken neck idea. I'm going to use that in the future. Okay, the rat tail maggot's pretty easy. It has this long spherical to breathe air at the end. They are very pollution tolerant. You can't see their head at all. So it's just like this maggot looking thing with this long spherical at the end. And then soldier flies are pretty easy. They are leathery looking and they have flat bodies. So, and if you see something that looks a little bit like an elmid, I think, but it doesn't have any legs. It's just this like hard looking leathery, and it's found in muck, and you can see its head. And then everything else goes in the somewhat sensitive true fly. So if you can teach yourself the 6 of the other ones, which in reality, you're not going to see Blepharocerid very often. So there's really just the Aetherissids and the Dixids, and then the mosquito larvae and those 2 other pretty obvious ones. It's not, if you keep it simplified like that, I think it's less overwhelming. The other ones you'll see a lot of times are black fly, which look like little bowling pins. You'll see crane flies, which I think look like the things you would eat if you're on the show Survivor. They're usually just really chunky looking and squishy looking. And they're often found in leaf pecks because that's what they do, is they eat leaves. And then midges are what Paul was talking about earlier. You can see their heads, but this one, he's right, this one's pointed down versus that pointed up. And they don't have any prolegs usually. Sometimes there's one right here. These are the 3 you'll most likely run into that would go into that middle category. Here's the black fly that looks like a bowling pin. I'm going to go a little quicker because we're running out of time. Here's the crane fly. See how it's like just big and kind of, I don't know, juicy looking, meaty. You can't see its head either. And the end varies quite a bit with the Topulids. Here's another one. And here's some other images of the midges. Sometimes they get red, so those are the blood worms. So that one is easy to tell, although they probably lose their color a little bit in alcohol. And they do have prolegs, but they're not super obvious. There's not multiples along its body. And then we have the true bugs, the hemipterans. They all have these mouth body parts that pierce and suck things versus chewing. Their wings are hardened near the base and then membranous everywhere else. So sometimes they'll even fly out of your pants. The adults look the same as the young, and they're found in many different kinds of habitats, but they like the slower flowing ones. And then they, like I said, they all have these piercing mouth parts. So when you get them under a scope, you can see the different types of different mouth parts, but they're all more of a sucking versus chewing. Be careful, they do sting. This has only happened to me once in my 20 years, but it's already happened to my son who's 12, just on the side of a lake. So just be careful when you are getting them out of the net. That's how I got stung. A lot of them are on top of the water as well. Water striders that you see, water scorpions, which can't remember her name. Nancy this morning showed a pretty cool picture of. She also showed a picture of Bella stomatid, water boatmen swim across the water, and back swimmers. Which one of these has the really red eyes? Which one is that? Boatman?
It's the boatman, I think.
Yeah, the boatman, yeah. Do you have anything else for these ones, Paul?
They're all so unique from each other. It's like you just kind of have to learn each group, no matter what level you want to do this one at. Much more visually distinct than other groups.
Yeah, I think the two hardest ones are the boatmen and the back swimmers. I just sometimes get them messed up with each other. And then we have unique ones like the scud or the freshwater shrimp. Those are not hard to identify, but they are hard to catch, especially if you get to a stream that has a lot of them. I'm interested in how volunteers get them all in the jar. Then the one that can be confused with them is sow bugs, but they crawl instead of swim all over the pan. They have 2 pairs of antennae and 7 pairs of legs, and they're flattened dorsal ventrally. The adults look same as the young. And we have crayfish, which everybody is familiar with. We don't collect them, but we do count them. We have snails and mollusks. Again, we don't collect them, but we count them. Especially, this is important that for the Unionidae, I'm sure Joe talked about this. If any of you went to that talk today, you need to put them back carefully into the sediment. And we don't count empty shells. You have to find a live one in order to count it. Some of them are really tiny, like the pea clams. For the mollusks, the snails, there's many types. Again, we don't collect them, but we count them. But we do want you to watch out for the New Zealand mud snail. If you find a bunch of really small snails, take some of them and let Paul or myself or the invasive species people at Eagle know, and they'll somehow get the sample from you and identify them for you. Or they'll find somebody locally that can help you out. And then lastly, we have leeches and worms. So that is it. I'm going to take just a few more minutes to let you know that we do have online now the biological monitoring of everywhere Eagle has sampled. So it's out there. I just want you to know about it. I think most of you have known about it from other ways we've told you, either via our social media, but it's a really good way to see where sites have been sampled in your watershed, maybe see where there's gaps where additional sampling might help. You can also get contact information for your watershed biologist. I would like to encourage all of you to try to figure out who your watershed biologist is and contact them and let them know that you exist. I know some of the biologists got out with some of the groups Elgrow, they had a biologist go out with Friends of the St. Clair went out with the biologist when they were doing their own sampling. So I can't promise, but I do think that if you reach out to the biologist, there is a good chance that they'd be willing to go out with you as long as you sample, if you plan a day to go together, or more importantly, they could come on your ID days, which you are usually just yourself or a few experts identifying your bugs. If you plan that with the biologist, I bet they'd come and help you out. And maybe you can learn down to family. And that's it. That's how I'm going to give it up for now.
All right. Thank you, Tamara. Take a breath. I'm getting tired too, so I'm going to go through this next part, but I may have some brain malfunctions as I go through it this point of the day. But just in the last 20 minutes we have here, I did want to take the opportunity to share some of the data explorations that I've kind of been doing with this system. You can see that okay, Tamara, the practice data sheet?
Yes, I can see it.
Okay, great. Because yeah, this WQR rating, water quality rating, is still, I still consider it a new thing, even though we've been teaching it for 2 years now, because we had done the old method since 2005. The old method that we used was a method kind of homebrew created by DNR staff, and what we switched to was something that is more nationally used and peer-reviewed and stuff like that. So we kind of just went this way to simplify and standardize the approach. And so I've been kind of thinking about, what does this number mean? What does it mean for me in the Huron River? What does it mean across Michigan? So this is just an example of how to calculate it. I don't think I'll go through it. It's pretty easy. I've even given it to high schoolers. They do good with it. They're used to this type of thing that they have to do it in class. Multiply, add, divide. You end up with a score that's somewhere between 0 and 10, where 0, high water quality, 10, low water quality. And you can do it the exact same process at the family level. You just have more numbers to chug. And because HRW, even though this is a new procedure, HRWC, both me and the people who came before me have always identified down to the family level. So it was pretty easy for me to convert all of my data to this system. And now I have since 1992, I have results that use this new system. So what that has done is enabled me to kind of think about it in a long-term scale. So that's kind of what I was going to show. For those who came to the June stream training, I think it was just Josh and Tamara and Rachel, I think, is here. This is the same ideas I presented as we were sitting by the Huron River that one day. But when we had to do this sudden change in our workshop, I decided to pull this out and dust it off and think about it a little bit more, because hopefully this can help other people. So sorry for you three, it's a bit of a repeat. I think everyone else is just kind of new. First of all, what is this water quality rating? It was created by William Hilsenhoff. He was a professor. I always get these two schools confused. Sorry. He was either Minnesota or Wisconsin, but he was an aquatic ecologist. And he assigned these ratings at the species level, actually. And then over time, as he finessed his approach, he started scaling it up to genuses and to family level, to try to make it easier and more applicable to broader swaths of people, because hardly anyone can do species level ID unless you're a real specialist. So what we have now is all these numbers assigned to families. And so what I did was then I averaged those to get to get to the level that we do it at. The way he does this is through laboratory studies and field studies to attach these numbers, and it specifically refers to organic pollution. So it's their vulnerability to to all these things that you can see on the map here: the wastewater, the runoff, it's fertilizers, it's nutrients, pesticides. It's all these compounds holding carbon, things that are burning oxygen as they decompose. So this is a number that's strongly related to oxygen levels. Okay, so that's what these numbers specifically get at. However, this is an important thing in stream ecology. Habitat diversity and habitat quality and flow and all those pieces that we generally are out there trying to fix with our restoration projects, they're connected to organic pollution. If you have bank erosion, you are putting this organic pollution into your creek. Flashy water flows with flooding coming in and like runoff from stream or from roads coming in very quickly and making things really turbid. That's carrying organic pollution. So while specifically Hilsenhoff is organic pollution, it's so highly correlated with all these other things out there that we're trying to fix. So that's why it's a really useful number, even though, once again, it's directly organic pollution, but it's all of these things are connected in some way. So just a quick shot of HRWC data. This is where I work, and Kate is here. Kate works here. We sample 60 sites. This is approximately since 1992. Some of these we go to every event, but it really just depends on the number of volunteers we have. Sometimes we only go to the sites every other year. And some of my worst sites that just haven't changed in years and years and years, at this point we only go to every 5 years, just as a checkup. But some of these are so degraded they just hardly ever we hardly see anything. So I don't send people there often because it's not as good of a volunteer experience. By the way, that's something you guys can do in your own programs as you start developing longevity in your data record. So I have 60 sites. Now, if I look at diversity metrics, I'm counting the number of families, counting the number of ephemera, Plecoptera, Trichoptera families. What I see, I have 13 of the 60 sites are showing actively, they're either going up or down significantly, statistically significantly, in their long-term trend. All right. However, only 3 of those 60 sites are showing long-term changes when I'm looking at just that WQR score. So this is kind of interesting, and this is kind of what I'm going to focus on. I'll show you a graph or two. So my general conclusion is this WQR score is very resilient, and in order to change that, it requires a whole community shift to get that number to change. So it seems like a very solid number. Let me show you. This is Man Creek, for example, and here's the WQR number. And it hovers right around 4, but hardly ever gets away from that, even over all these years. Generally flat over time. As an aside, you learn this stuff in college. Watch out for the graph scaling issue, right? Like I'm looking at 0 to 10 here, and it looks like it's hardly changing. But if you just change your y-axis to a smaller number, suddenly it looks like it's changing dramatically. So, watch out for that. And actually, this is a different site than what I just showed you. This one is changing significantly. It's only changing from about a 4.5 to a 3.5, right? So if you look at it under this scale, it doesn't look like anything's happening. So just watch out for that when you graph your data. Anyway, going back to Man Creek, very flat, nothing changing here. But here are actually my other metrics, and I'm seeing significant increases in my EPT families, my sensitive families. These are families where I'm just getting a 0, 1, or 2 rating. The ones that are just most pollution intolerant. I actually am finding 6 nowadays when I used to find 1 or 2 kind of in the old days. And this spot does look like it's getting better. So that's kind of strange, right? It's as flat as can be with the water quality rating, but if I just look at like family counts, it is changing. So that's just something to think about for me. And so like, why isn't it changing? And I looked at just 2 samples that I took from at this location, 1999, and we have a sample at 2020. The abundance is about the same. This WQR is exactly the same at 4.1. And then you can see how the diversity has changed over time, has gotten better. So better diversity, picking up a lot of sensitive insects, but it's still the same number here. And I mean, there's reasons for it. Here's the full data breakdown. Isonychia is a really sensitive mayfly. Whoops. Isonychia is a really sensitive mayfly. I found 14 where I only found 0 before. But I'm picking up tolerant species at the same time too. So water scorpion I'm finding, this damselfly, this is a tolerant damselfly, giant water bug. So I'm finding tolerant stuff too. And really the pickups on the tolerant species are offsetting the gains that I am making on the sensitive families. No more days of stonefly, finding those. I also lost some things. So anyway, I guess the point here is that you really need to use all of these tools in your toolbox when you're trying to figure out what is going on at your sites. And I never want to leave you the impression just because WQR is on your data sheets, that doesn't mean that's all that matters. It's kind of a fun one for the volunteers because they get to do the math and stuff and figure out like they're coming to the scientific answer. But when you look at your data, I want you to think about all this stuff, these different metrics, not just the WQR, but all these metrics can play into understanding what's happening here. I do think Man Creek is getting better. It's not shifting fast enough to show a reflection in that WQR score, but I do think the creek is showing improvements, and it's just something to watch over time. Eventually, maybe it will, but I think it takes an awful lot of change at a site to shift that WQR score. So that's kind of like my conclusion. So when you look at your own data, I want you to be, I guess, thinking about similar things, and I want to know what happens when you do this. Like, do you see the same thing I do? Because right now I'm just looking at my own data. I don't have everyone else's data entered yet, because we're just trying to figure that out. So, I'm interested to see what you are finding on your sites. If it's same, if it's different. So, let me just fast forward here. And then the final point I want to make is that the scale that we have on your data sheet is not necessarily where I want to end up. This I stole from Illinois. This is how I think it's their Department of Environmental Quality or Natural Resources uses this particular scale. However, typically Michigan streams are better than Illinois streams. Humble brag, we have more forests, more natural lands. Our streams are generally more diverse and healthier. And so what they have decided that their scale may not be what we want our scale to be. So as we all work together in developing the data, we might end up with a different set of breakouts for what is good in Michigan versus what is fair in Michigan. Like the worst stuff I have in my watershed is a 7.3, which it's in the fairly poor category. However, when I go to those sites, in my mind, they are very poor, right? So I just lack the full breadth of knowledge of what streams how bad they could possibly get. If you go to a stream and all you find is leeches, for example, I don't have any of those. And maybe those are really, really rare in Michigan, but they might be common in Illinois. So it just goes to show, I think we need time to develop this properly. And like knowing how your streams fall with this rating system will be interesting and telling. And it's the kind of thing I want to have conversations about, and maybe future maybe this is a topic for next year MiCorps conference, is to have you all bring your data and we can combine it all together and see what's going on. I'm curious about it, and I want to. I'll never be fully satisfied with an answer, but I want to get closer. So it's kind of the thoughts that have been running through my mind with that, and for all of you, when you report this out to the public, do it cautiously. Do it, like any scientist reporting data. You hedge your words. Don't come across as too strong, as we absolutely know this to be true. There's room for interpretation, and things change, and so yeah, and it will change. I think we'll change this in the future. We just can't do it yet. Yeah, so those are my thoughts. I can stop talking. I don't know if anyone has a question. I'll bring up the chat, or someone else can speak up.
Yeah, we have a few minutes left, just a few, 3 minutes or so. So before the break at 2:40, and then we'll all reconvene at 3 o'clock for our keynote speaker. Any questions for Paul? Josh just put one about comparing the old data sheet to the new one if you don't have the samples. Is there any way to do that?
I've tried, and I just can't get it to a satisfactory point. So I think the answer, though I'm always ready to be convinced otherwise, is no. I don't think you can. I think you need those samples, or you need your old data identified down to the family level.
That's what I was just going to say. Yeah, it's one benefit and of going down to family level, I think. So you could go back. I know the Little Manistee, so it's the Lake Mason Conservation District. They had an intern who did that, who went back for the last 5 years, I think. And
yeah, wasn't it Chelsea? I think it was Chelsea said she did it.
Maybe, yeah.
Yeah, so she she put the hard work in there to do that. But yeah, not every group has all their old samples, or we tell groups to save their samples, but not everyone has the storage space either. Paul, do I run my events as a group day? Yeah, we do go out. We do go out all on the same day, and then we have a separate ID day where anyone who wants to comes in and works on the samples. Though ultimately, as any group who has a QAP knows, it's the program manager or the people you've designated as your experts who are getting the final call on all ID, right? It's not up to the volunteers what the final ID is. That's the responsibility that lies on the program manager. So I do end up not redoing, but looking over everything that the volunteers do to get the final data.
Hi, Kelly. Yep, I am the biologist for the Pawpaw River Watershed. I have been for 15 years or so. So yeah, feel free to connect with me. We don't sample the Pawpaw River Watershed again until 2026 as a targeted watershed. That doesn't mean we don't at all, but I also am interested in helping out with your ID days if you need help.
Okay, so I'm going to answer Sarah's question, but I want everyone to know that they're welcome to leave and take a break for 20 minutes, and then we'll reconvene at 3. Sarah, you're asking, as far as bivalves go, are we supposed to count all of them, even if they're invasive? What if volunteers can't ID them? Should they still return them to the water rather than jar them up for bug ID day? So yeah, because we simplified the process so that you wouldn't have to identify your bivalves or your clams or your mussels. It's just like you call them all the same thing. So so all you really need is them to have a count out at the river, and then you can return them right to the river. As far as identifying invasives, I mean, the exception is the New Zealand mud snail. We don't want that to go back in the river. The chances are, if you're finding it, it's already everywhere there, right, Tamara?
Yeah,
so maybe returning
say.
them. Don't stress about returning them, because it might be too late for the little bit that you're pulling out. Isn't going to make a difference. But the reason we don't want volunteers keeping those things is if they're finding invasives, they're already very widespread. And putting them back doesn't make a difference. And we don't want to, our lack of knowledge in their identification means we don't want to start pulling stuff out that might be threatened or endangered, especially when it comes to the mussels. There's just, 50% of our mussels are endangered or threatened at this point. So we don't want volunteers accidentally keeping those and putting them in alcohol. Anyway, I hope that answers your question. Or do you have any tips for identifying pupa to family? We have some guides that help a little bit, but it's still difficult at times. I don't have any good advice. My organization has never identified them. We always treat them as unidentifiable, and we don't include them.
We do the same here at Eagle. I mean, if you find a pupa, you're going to find a larva. So it's just not, I wouldn't spend the time on it. It's not necessary.
You're welcome. Okay, everybody. Thanks for being an attentive audience. I hope. I couldn't see your faces. I'm assuming you were attentive. And it's great working with you all. I appreciate what you do. Keep up the good work and keep working on those bugs. I mean, it really just takes repetitive, you just have to keep doing it. Go back over and over and over again to really learn them good. Yeah, thanks, Kate. Okay, guys, have a good break. We'll see you in a little bit.